I'm going to show how to implement logical operations in Affinity Photo's procedural texture filter. Sometimes I've seen a function used in a certain way and I didn't really have a conceptual foundation for what that was like. And I saw this with the step function. Someone was using it in a way that just seemed so strange to me. And then once I found out that they're using it as a greater than or less than function, then I had the conceptual foundation to understand that. I'm going to go over the logical operations that are available in the procedural textures. The background image I'm using here is an implementation of an exclusive OR function, and I have a combination of Perlin noise and cell noise, and then I have the exclusive OR function applied to this. I'm going to be covering 4 different logical operators: not, and, or, and exclusive OR. These can be represented with gate symbols, as I show at the top of the tables here. They can also be represented with operating symbols. For instance, the line over the A can be used to represent not, the dot represents and, the plus represents or. The plus with a circle can represent exclusive OR. We're going to look at each of these and explain how they work. Not is the simplest one. It has only one input. The rest of these all have 2 inputs. You can see that if I have an input A, the output is the opposite of the input. The other thing to notice is that these all have just 2 states, either 0 or 1, and so they're closely associated with binary numbers. If I input a 0, the knotted value of 0 is 1. If I input a 1, the output will be 0. Down here I show a more complicated example. I have 0, 1, 0, 1. You can see the output is the opposite in every case. Next I'll look at the AND. Each of these logic functions are fully defined by the truth table. So these boxes underneath here are called truth tables, and they define every possible combination of inputs and outputs. For the AND function, we see that the output is always 0, except when both inputs are 1. Down here with the longer example, I have you can see that these are only 1 when both inputs are 1. The OR function is a little bit different. That is only 0 when both inputs are 0. Otherwise it's 1. So down here with the longer example, you can see it's always 1 except where both inputs are 0. With exclusive OR, it's a little more interesting. Exclusive OR is 0 if both inputs are the same, and it's only 1 when both inputs are different. So that's what I show here. If the 2 inputs are different, it's 1. If they're the same, it's 0. I'm going to start with a new document. I'll just leave it at in XGA mode and make sure it's in RGB mode. I'll create that. I'm going to just fill it with black. I'm going to start by adding a live procedural texture filter. I'll add a single equation, assign that to all 3 channels. I'll add a single real input, A. I'll call that scale, and bring that up to 4. I'm going to work with a Perlincubic function so I can see what's going on. I'll add a Z input for the octaves. I'll just set that to 10. I'll add a 0 to 1 range input S for the smoothness factor. Call it smooth. Set that about 0.5. And then I'll start by creating a coordinate vector. V equals vec2 rx comma ry times a divided by h. And then I'll just look at the Perlincubic of v comma o comma s. So there it is. Some places are white, other places are dark, and then it's sort of a grayscale image. Now the first one I'm going to look at is the step function. So if I take the step of 0.5, comma, and Perlincubic, those areas that have values less than 0.5 are black. Those variables that have values greater than 0.5 are white. But is this a less than or greater than function? So I'm going to try a numeric value. I'm just going to copy this whole thing and paste it down here. I'm going to turn off these inputs and I'm going to turn on these like that. I'm going to change this to 0.3 and I get black. Is 0.5 less than 0.3? No, so I return a value of 0. Now I'm going to change this again. I'll make this 0.7. Is 0.5 less than 0.7? Yes, so I return a 1 value, so it's white. So step, in this case, is the less than function. Now, in most shaders, I believe step is a greater than function, and so this is a little bit different than that. All right, I'm going to delete this one, go back to this, and I'm going to think about this again. I'm going to replace this with the slider, I, and add another input for that, I, and I'll just call this the edge of my step function. Okay, and so when this is about 0.5, I have this. So now what I'm asking is if I is less than Perlincubic, it'll return a 1 value. If I is greater than Perlincubic, it returns a 0 value. So I'm going to show the not function first of all. So to get this started, I'm going to set this up as a variable. I'll call it T1 equals all of that. And I'll just put T1 over here to show that it's still there and it still works. Now, to get the not version of this, I take 1 minus T1. And it just makes any place that was black, it changes to white. Any place that's white, it changes to black. So 1 minus a variable is the same as the not function. Now, this really only works if you've limited the range of your variable to between 0 and 1. And the step function will do that. It will limit the range of your variable between 0 and 1. The next thing I want to do is to look at the and or functions. Now I'm going to set up another variable. I'll call it T2. I'm going to set this one to the cell noise function, and I'm going to use the distance version of that. And I have to put in the v.x and v.y as individual coordinates in the cell noise functions because that's how they require that. And then I'm going to add another input to this one. I'll just give it, I'll call it b, and I'll set that up as a custom variable down here with a real input b. Set that up to that. So there's my cell noise function. And then I can put a step function around this to get the less than. I'll just set an I value for this one. As I move this over, I can get lines like that to show up. I think I need to have an I1 and an I2, so I'm going to delete this one, and I'm going to add 2 of these. I'll call this one I1, this one I2. This one will be edge 1, and this one will be for edge 2. And I'll just rename this distance. I'll change this to an I1, and I'll change this to an I2. To implement the AND function, you just use multiplication. I know these are limited between 0 and 1. 0 times anything is 0, and 1 times a value is that value again. So I'll take T1 times T2, and that gives me this. Any place where one of them is blacked out, and only places where both T1 and T2 are white will we see a white value. We're going to take and make a copy of this and add a new equation, and I'll paste it in down here. I'm going to turn off the alpha, turn off all 3 of these, and turn on these 3. Now, to implement the OR function, I'm going to put in a plus here. Now, if either of these has a 1 value, it returns a 1. If both of them have a black value or a 0 value, it returns a 0. Now I'm going to implement the exclusive OR function. And so the exclusive OR, given my variables T1 and T2, can be implemented by T1 ANDed with not T2, or T2 and not T1. Okay? To implement this, I'm going to multiply this by 1 minus T2, and I'm going to multiply this one by 1 minus T1. The way the exclusive OR works is it will be 1 where they are different from each other, and it will only be 0 when they're the same as each other. Okay, and so that gives me this pattern where it's alternating and crossing back and forth between black and white all the time. So I can bring this up to show more of these, and then I can change the edges on these like that or like that. I'm going to look at the OR function again. And you may have noticed that when I add these 2 values together, T1 plus T2, if they're both 1, that will add up to 2, not 1. So I can tell that if I put parentheses around this and divide by 2, I can see that I have a white, a medium gray area, and then a black area. So I have 3 different levels of that. Now if I did want to restrict this to between 0 and 1, I can use the clamp function. So if you look at the clamp function in the documentation for Affinity Photo's procedural texture filter, there are really 4 different clamp functions. There's one just called clamp. So if I take the clamp and divide by 2, I now see that it looks like it's between 0 and 1. In fact, if I add let's say if I add a 0.25 to this, you can see that it brings it up a little bit. So clamp, with no other inputs other than just the texture, will limit those values to the range of 0 and 1. I could also add other values, so I could add 0 and 1 manually, and that gives me the same thing. I could divide by 2 just to check, yes, or add an offset of some small amount like 0.25. And yes, so that's working the same way. I've set it back to clamp of T1 plus T2. So clamp is one way to ensure that the output is restricted to between 0 and 1. I'm going to go back to the exclusive OR function again. For this one, I'm going to add a adjustment and add a gradient map to it. We'll choose the default like that. And you could adjust this to some other colors, make it look cool. That one doesn't look too bad, just like that. There are lots of applications for logical operations. If you come up with something cool, please let me know by leaving a comment for this video. Also, let me know if you have any other comments or questions, and thanks for watching.